Hi, I'm Carolyn Van Slyke. I'm a software developer at Microsoft, and I'd like to talk to you today about why are deployments still hard, and what are we doing to make that easier for each other? So really, I'd like to talk about a new thing that maybe you haven't heard about, which is called CNAB, Cloud Native Application Bundles. What problems do it solve? Where could bundles help you? Or maybe they don't help at all. What I'm not going to talk about is the actual nitty-gritty details of the technology itself. I find that actually not useful at all. I don't want to dive into the details before we figured out if it's really going to help you at this point. So that's a big acronym, but for the remainder of this talk, I'm just going to call them bundles. Stepping back a bit though, what is this specification, CNAB, bundles? Think about what Docker did for applications themselves. Think about how much easier it became to deploy an application like Nginx or your own line of business applications after they became Dockerized. But now think about larger deployments where you had multiple applications that need to be coordinated together. An entire software solution or a suite of microservices, for example. There's still a lot of bash and hope, essentially, holding that all together and making your deployments work. And that's what we're trying to do with CNAB, is take, maybe not the magic, but what really worked to make applications deploy better when we put them inside of Docker, and do the same thing for deployments. What does that solve, though? We're taking a deployment, we're packaging it up into a bundle, and this becomes an artifact that we can version and then distribute and give to each other. We call it a deployment, though. What's inside of that, right? It's not just the app, right? It could be multiple things. It could be multiple components, all 100 of your microservices. It could be essentially your entire suite. It could involve all the infrastructure necessary to support your application. Maybe your app needs a database. Maybe it needs a load balancer, all sorts of things. Maybe it's on the edge. The dependencies, the tools necessary to run it, like Helm and kubectl and terraform, the scripts, the credentials, everything, all the little things that you have to deal with when you go to do the deployment. Essentially, there's an orchestration happening necessary in order to have a successful, repeatable deployment. And that's what we're trying to put together inside of a bundle so that you don't have to deal with it and remember all these little bits and pieces every single time you go to do a deployment. In addition, we'd like to have workflows built into bundles and tools that understand them so that we can have tamper-proof deployments. So you know that what you built and what you tested is what you're deploying in production. Now, bundles in CNAB is a specification. You can't pick CNAB off the shelf, download it, and use it. You need a tool that implements that spec. So the rest of the talk, I'll be using Porter as an example. Porter is in the CNCF. I'm really excited about that because it happened last week. I'm one of the maintainers and co-creator of Porter, so selfishly, that's what I'm going to talk about and use as a demo for the rest of this. Another reason why Porter is kind of interesting to look at is because it uses the entire breadth and depth of all the various sub-specifications inside of CNAB. So it's kind of useful to look at for what can CNAB do. Now I could go feature by feature and be this is why you should use bundles. It's really cool. But ultimately, that's not terribly convincing. What I like to talk about is why, Carolyn, why am I using bundles? What got me excited about it and why I'm using it on side projects and trying to get management to use it on various things that I'm doing. Because I think that's honestly, it's more fun to talk about. It's more fun to look at. And then we'll kind of look at all the other features later that big companies think are interesting. The largest thing that I think is important to grasp about bundles is that they have every single thing that you need to deploy smooshed inside of a Docker container, okay? Bundles, Docker containers, they could be something else. Actually, you could make a bundle that's based on a VM. But for the moment, all the tech assumes a Docker container. And what's neat about it is that say your deployment needs Helm, needs kubectl, needs customize, it needs terraform. All of that's inside the bundle for you, so you don't have to go hunt down and find it. You don't need to find the right version. You don't need to get all your coworkers using the exact same version for all the apps they're deploying. So let's look at an example here. I'm a brand new person on the team, and I'm going to set up a cluster. I'm going to need to make the cluster, first of all. And so I'm probably going to need kubeadm, or maybe I'm making it in the cloud, and I need one of the cloud providers' CLIs. And I'd like to be secure, so I'm going to have a secret store using one of those technologies as well. And I'm going to use secret store CSI to connect the two, and I'm going to install that using Helm. Now, I know this looks like alphabet soup here, but that's kind of the point, is that when I think about what it looks like with bundles today, all of these tools are going to get installed on my machine or installed on one of the machines where I'm doing the deployment from. I'm going to have the cloud provider CLI, Helm, kubectl, blah, 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 blah. But if I use a bundle, it's always the same two things. It's always going to be Porter, and it's always going to be Docker. It doesn't matter how many apps I install. It doesn't matter how many tools they need. It's always the same two things on my machine. So next, looking at what bundles give you is that they encapsulate all of the logic, all the things you need to kind of manage in your head or document or automate somewhere for your deployment. So thinking back to my team cluster again, very first thing, I need to clone the repository necessary that has all my scripts and everything to do deployment. But which repo is it? Is it my applications repo, or do I have like a mega DevOps repo somewhere? Do I need to set a whole bunch of environment variables that have secrets in them and GitHub tokens and all sorts of top secret things? How do I know what values to put in them and where to put them? All right, cool. I'm finally to the point where I'm going to run some commands. But what are those commands, and what are the flags, and what's the order, and all sorts of interesting questions kind of pop up. Well, let's say someone on my team was being really helpful and they scripted it. That's great. It's in a script folder, and there's 15 other scripts, which is the one I run. Okay, no, this is even better. Someone made a Docker utility container. Perfect. Okay, we're actually halfway to a bundle at that point, because bundles are also essentially Docker utility containers. But what volumes do I mount? What environment variables do I pass? Essentially, it comes down again to what are all the flags I pass? How do I know what to do? There's a whole bunch of institutional knowledge. No matter how much I know how to use Docker or Helm or Terraform or whatever the tool or technology is, I don't know what to do for this specific deployment. Everybody's a snowflake. It's always stressful. So let's think about what it looks like with a bundle. I mean, it's not magic, but after you've done a couple deployments with bundles, they start to look very familiar, and you almost kind of know what to do as long as you have a little bit of information to plug into it. You just need the bundle tag. That's like the little piece of information that says, this is where I find the bundle, so I can download it. I don't need to know what tooling the deployment actually uses inside of it, though. I have no idea. Does it use Helm? Does it use Customize? Does it use Terraform? It doesn't matter. It's in the bundle, and I don't have to deal with it. Honestly, as I'm learning how to do deployments on my new team, this is a lot less intimidating. So I said tag, and you may have been like, what kind of tag is that? It's a Docker tag, or an OCI registry, to be very specific. And what that means to us is that you don't actually have to deploy new infrastructure to support bundles. As you're pushing your own Docker images all around, you can use that same infrastructure to push and distribute your own bundles as well, which is kind of nice. So it means that you can easily find and see what bundles there are to install and what versions you have. And it also kind of just builds upon this familiarity. If you are familiar with Docker, then you feel like, oh, okay, bundles are also very similar to Docker. I mean, they're built on top of that technology. They use tags. I kind of know how to work with this already. It doesn't feel like as much to learn. So I kind of cheated a little. I like hand wave that whole install command, and I'm like, look how easy it was. And then I said like, oh yeah, whatever, those flags, who cares? This is how you figure out what those flags are. Bundles have the ability to say, here's everything a bundle can do. Bundles will tell you all of the credentials that they need up front, not like you figure out what it is halfway through when it complains, oops, you need an AWS cred. It'll tell you all the parameters and flags you need to pass and any custom actions they may support. So every single variant of an install command or like an upgrade command is right there, baked in. There's no surprises. You always know what type of install or upgrade commands that you can call from here right up front. It basically teaches you how to call the bundle. So switching gears a little bit, thinking about security. As a developer, I'm just terrible with security, to be honest. If you looked at any machine I have, you're probably going to find like a plain text GitHub token on my machine. And to be honest, raise your hand if you ran env on your machine. You probably find a whole bunch of plain text, interesting bits too. So Bundles has a way to kind of help you with this. So let's look at what we're doing today, though. Let's look at our shame, most developer shame, which is we read the docs and we go, this is what credentials we need to do our deployment. And then we look at, okay, we need to define this environment variable, make these files, all these important things. And then every single tool, though, needs those credentials differently. Some are really smart, right? Like Terraform knows how to talk to a secret store like Vault or anything like that. And they actually know how to work with encrypted credentials, which is great. But a lot of them don't. A lot of them, they need them passed as parameters, and you have to put them essentially unencrypted on your machine somewhere, which is not as much fun. Or you have to be really good at working with these other tools, which, to be honest, most devs aren't that motivated. And then when you're done, you have to clean up your machine and wipe it all down, which in production we do. On all our other machines, we don't. What it looks like with bundles is you do this one-time step where you say, hey, bundle, what credentials do you need? And I'll tell you where you can find them. Some of them may not be terribly sensitive and they're on your machine. Some of them may be in your own personal vault and they're your credentials to AWS, or they're your personal GitHub token. Others may be like a team vault, and because you're not paying for your team's infrastructure, and they'll be like, here's your credentials to gcloud, things like that. And then when you run install, just in time, the bundle will go off and look up the credentials it needs and inject them into the bundle, use them. And when the bundle's done running, the entire Docker container is destroyed and all your credentials are safe at that point. And what this does is it limits the exposure of your credentials. The local machine essentially doesn't see them, and nothing sticks around for very long. Now, so far, we focused really a lot on the ops side, the deployment side, but when you're writing the deployment scripts themselves, there's a lot of things we can do as well to make it a little bit easier. I don't know if I'm the only person out here, but I'm not that excited about writing bash all the time. It's not my favorite thing to do. Mostly because every line of bash I've ever written is me copying from a bash script I wrote the other week. So what Porter lets you do is it's a declarative syntax, and it has a lot of built-in helpers that let you use tools that you're already familiar with. So if you know how to use Helm, you're already using Helm, you've already written a bunch of Terraform scripts, it knows how to work with that, and you just reuse everything that you've already written so far. Now, a lot of my bash, I don't know about yours, but a lot of mine is doing error checking and seeing if that last command actually worked and was successful. Or scraping outputs from the command and looking through JSON or looking through the text and getting little values out of it that are useful that I can then pass to the next command. Or getting state or useful information from a previous run of my bundle. Maybe it made a database and I need a connection string. And all sorts of things like that. They need to pass around and save for a little bit and then send to the next command. Essentially, what I'm doing is playing with Lego. And what it lets me do is take tools that were never really meant to work together. They weren't written by the same developers. They weren't created with adapters for each other. And I can just stack them on top of each other and send data between them pretty seamlessly. What this ends up looking like, yes, it is more verbose than if you just straight up wrote a command. But when you build in things like error checking and like scraping and all these other things, it ends up being useful because you can focus on what the deployment is actually doing. I know I'm creating a database, I'm scraping out my connection string, and then I'm sending it to Helm. And you're able to focus on exactly what the logic is that the deployment's doing, and not the side effect of all the bash necessary to make it happen. So why is it that companies like bundles? I talked a lot about what the people on the ground are doing, but why are companies picking up and trying bundles? One, it lets them deploy across an air gap where maybe production doesn't have access to your CI pipeline artifacts or doesn't have access to the internet. They maybe want repeatable deployments where you guarantee that whatever you run once, when you run it again, it'll have the same effect. Supply chain security. Where what I built and tested is absolutely what's going to happen in production, and it can't be tampered with. Or if you notice that YAML, you're able to get a lot of insight into, I'm running a Helm command, now I'm running ARM, now I'm hitting gcloud, or I'm going to CloudFront. This is information that if you were just using a bash script would be very difficult to get insight into, and companies find this type of data very interesting. So when wouldn't you use bundles? Because let's be honest, like this is kind of cool and I find it really interesting, but it may not be the right thing for you. If you're using a single stack and you're happy, stop, you're good. No need to do it. If you're using a PaaS or using managed infrastructure, and you're not creating your own clusters and you're not doing all this, and you're just deploying your one application, and you make a single Helm call to deploy your release, you're not chaining together multiple tools, you're not doing multiple calls, you're not grabbing outputs from one command and trying to send it to another command. These are all things that bundles are pretty good at. And if you don't need it, what's the point? You can save yourself a lot of time and not look at this much further. I mean, there's a bunch of enterprisey stuff there too, as well. But if you don't need that and you're happy, go forth. You're done. Because this is really what it would look like. If you're using Helm today and it looks like this is what it would look like with Porter. And there's really not a lot of difference for the person doing the deployment. It's really not worth switching. If you're using Windows, it's may or may not be useful to switch. Inside of Microsoft, we have switched. I should hope so. We helped write it. But bundles can run on Windows, so that's cool. When you run the bundle, though, the commands are executing inside of a Docker container, and that Docker container is a Linux container. So if your commands, the executables absolutely must be running on a Windows architecture, it won't work for you. We have that on the roadmap, but if you try it out today, it's not going to work. So be patient, or I don't know, come back in 6 months. Yeah. So I want you to remember about bundles is, again, everything you need is inside the package, the bundle, ready for you to use. This should hopefully simplify deployments quite a bit. They're very easy to move around because they go over Docker registries. The way we manage credentials and secret parameters make things pretty easy to use as a developer. They're kind of friendly. And the authoring experience is incredibly flexible. If you've already written your deployment, you can really just pick it up and put it in a bundle and not rewrite anything, and you're done. If you're writing one from scratch, you can use that declarative experience that I showed you. And if you need super cool enterprisey stuff like supply chain security and all sorts of things, we got that too. So I don't know if you're interested or not, but if you are, come check us out. Go to the website, or we have Slack channels and mailing lists. Talk to me. Yeah, we'd love to hear more from you. And it's not fully baked yet. We have a 1.0 on the spec. Porter is getting closer to 1.0 as well, but we have room to make changes, and we'd love to hear your feedback. So now's the time to talk to us. Thank you very much.